Okay, we run map. Map is easier to wrap your head around because you have an equivalent in programming, right? You have for loops. Whenever you're doing multiple things, you can do map. The counterpart to map is reduce. And this is something that, again, you don't have a counterpart in your traditional programming. If you've done programming for years, you will not encounter this. Even in your desktop processing, you don't have an reduce equivalent. So again, this will take a bit of learning curve to understand what reduce is. Reduce is more like a statistical operation. Whenever you think of reducers, think about what statistical operation you want to do it. Fortunately, you don't have to write your own functions like you want to map. Earth Engine gives you a built-in reducer function that you can use. So whatever reducer you want to use, you pick the one that you want, and you can apply it. You can apply it on any of these different objects. You can reduce a list, you can reduce an image, you can reduce a collection, feature collection, and so on. And you can run a reducer by calling .reduce. Let's see some examples. If you have an image collection, and you can say .reduce, you can give a reducer. The reducer will run at each pixel of the stack of image. And let's say you want to do a median reducer. It'll take all the pixel values at each location, compute the median value, and give you that pixel. And you have a stack of images. When you reduce an image collection, you get an image. Does this sound familiar?
I didn't understand what the difference between reducer and map.
Yeah, so let's,
Sorry.
yeah. Map allows you to run a computation in parallel on many items of a collection. Once you have done the computation, you have to combine the result somehow. You say, I have all these images with NDVI. I want to create a composite, and that's a reduce operation. Like I want to create an image out of it, or I want to create a chart out of it. Here you just have whole images. Now, you say I have 30 NDVI images. What do I want to display? I want to display the median value of NDVI. So that's the reduce operation.
Because you're reducing it down from a huge collection to something smaller.
So this is the kind of big data programming style. When you do big data processing, you distribute your computation. All of your computation is done separately, and then you say, I want to collect all of this. And when you're collecting it, you said, I have all of these different things. How do I collect them? You say, give me the median value, give me the max value, or give me the list of values, and so on. Right? So those are the reducers. So map will distribute, reduce will collect that back. So if you reduce an image collection, it gives you an image. Does this sound familiar? Have you done this before? This is image reduction. Yes, we have done this creating composites, right? When we did .median, that is doing that. It's just running a median reducer on your collection. You didn't know this because Earth Engine gives you this shorthand function to do median, but we'll see how to actually implement them using reducers. Let's see this in code. Script 3A. I have this image collection with NDVI, 86 images with NDVI. I want to now compute a median composite. So let's say I want NDVI composite. Let's say with NDVI.select. So I'll select the NDVI band. Maybe let me just do this. Say NDVI composite. You can say NDVI call.median. This will give you the median NDVI. Right? All of you we have done this before. We have stack of images, and we just say .median, it will give you the median composite. This is actually internally running a reducer. So we can say I want to run the reduce function on this, and I want to give a reducer. Let's see what reducers are available. You have this module, ee.reducer. These are all the reducer function you can use in Earth Engine. Okay. These are all, you'll see these are mostly the statistical functions like mean, median, max, all of this. So we have a reducer called median, reducer median. I can use that. Both will give you an image, a median image. Both will give you identical images. If you add them to the map, they'll look identical. It's the same thing. This one is a shorthand command to run a median reducer. This is the full syntax. Okay. If you ask ChatGPT, ChatGPT will give you a very different answer. Right? Which one should you use? Well, the shorthand is available only for the top 10 most commonly used reducers. Mean, median, max, etc. But there are hundreds of reducers. So if you want to use a different reducer where there's no shorthand, you can use the second syntax. Okay? So internally, they are the same. There's one small difference in the output. You can see this one will give you an image. It says, I had an images with NDVI bands, and when I call dot median, you'll get one image with NDVI. When you run this full syntax, you'll get your band name is NDVI underscore median. It just adds the name of the reducer next to the band name. The shorthand syntax doesn't do this. The full syntax adds the name of the reducer to the band name. That's the only difference. Otherwise, the result is the same. You can, there's this function called regex rename, which just says, you can say rename all median values, everything, any band which has got a median, replace it with blank. So typically when I run the full syntax, I just run this. So my band names end up identical. Okay. And just to prove that they are identical, let me just add both of this to the map. So I'm going to add this NDVI composite. I'm going to add we'll add both to the map, inspect it. You can see exactly the same value, both of them. Right? It's just a different way of specifying the computation. So again, if you're just doing a normal mean, median, max, min, you can use this. If you want a different reducer, you can do this. I'll give you one example where you want to use this. A very commonly asked question is when you are working in a very cloudy region. Let's say you have a region where it's perpetually cloudy, and you have your collection, you have 100 images, 90 of them are cloudy, or 70 of them are cloudy. You will take the stack of images, and you say median. Median will be the 50th percentile value. So you have 100 values, 70 pixels are cloudy, and you say, now give me the median value, that will still be a cloud. So if you're working in a very cloud region, a median value will still be cloudy. So what's the solution? Earth Engine allows you to run a percentile reducer. We have EE reducer percentile. So median is a 50th percentile. So if you run this saying that give me a 50th percentile composite, this will be the median value. If you are in a very cloudy region, you say, even 50th percentile is cloudy, give me a 25th percentile value. So let's run this. I have this median. Let me just copy this code. We'll do a 25th percentile composite. So now I'm able to take this collection of images, and instead of per pixel median value, which is the 50th percentile, I'll say give me the 25th percentile value, because I'm able to run this reducer called e-reducer percentile. This is a pro tip. Many times people write to me, the composite still clouds in my composite. What do I do? Well, switch to 25th percentile. You'll see much better results. And you can do this. Again, when you run this reducer, you'll see that it adds this P25 to your name of the images. You can just easily remove this. And you'll have the same band name. And this will look much better. Let me show you the result here. On your finished script, I have this two composites. So this is your median composite. So you can see this is the city in median composite. I have the 25th percentile composite on top. You'll see it looks darker because, again, 25th percentile value will be darker. Like low values will be shadows, high value will be clouds. The median value will be the 50th percentile. When you switch to 25th percentile, it will be a little darker, but less chance of having a cloud. So if you do this in your region with clouds, you'll see much better result using this. And this is the point that if you want to run any reducer, you have to use the full syntax where there's no shortcut that is available to you. Okay. Let's do the exercise 3C here. Here we have an image. We are displaying the median NDVI composite. I want you to change it to your region and display a maximum NDVI composite. This is also quite used in agriculture, where you say, I want to know what was the maximum NDVI at that pixel in the growing season. So instead of doing the median value, I want you to display another layer of the maximum NDVI at that location. So try out this exercise 3C. So here in line 25, you can copy paste this and say, instead of a median reducer, find another reducer that can do. Yeah, the solution is to use the EE reducer max. If you use this full syntax, you can rename the max bands to empty, so remove the max. There's also .max, so you can also do with NDVI .max, which will work that, and then you can just display that. So this is showing that throughout the year, the NDVI changed, but this is the maximum NDVI at each pixel in the given year. Yeah.
This may be a more general thing. This ended up with an Earth Engine capacity exceeded error.
Yeah. Let's see if you've done.
So this was a different thing you said it was.
Are you doing it for entire state, or what's the region here? It's a fairly large region. So let's say you like this idea of doing this NDVI, and you say, let me do this for the entire country. Right? You say, I will select the entire country or entire world, computing max NDVI at 10-meter resolution. And you say, add it to the map. You'll see error, like Earth Engine capacity exceeded. Tile memory limit exceeded. That means Earth Engine, when you want to display something here on the map, this environment imposes a timeout of 5 minutes. That means if Earth Engine cannot complete the operation in 5 minutes, you'll get this error saying it's too much computation for me. That doesn't mean you cannot do this. It means you need to export. So you have this output. Instead of displaying it here, you say export this, export image to asset. Export it. Export might run for 1, 2, 3 hours, how much ever it takes. Once it's exported to an asset, import this asset and display that image. It'll work fine. Right? So as you kind of scale your computation, export is your friend. When you run this in your code editor, each user account has a quota. So if Earth Engine has 50,000 servers free right now, you cannot access all 50,000 right now. Per user in this environment, you have a limit. So maybe you have access only 100 machines. I don't know what is the limit, but you have some limit of how much RAM and CPU you can use per user. When you export it, you can share the full quota. So you have much more resources when you run an export. So you use a larger pool of resources, and it can run for as long as it needs. So whenever you see this errors on scaling, you can export and it'll work.
I'm not getting the image, the NDVI. Even I selected the.
I can take a look.
Yeah. Okay, so here's the solution that I've displayed. I've changed this E-reducer from median to max, renamed the max bands, and then just display this. And you can see this for this region. This is the median NDVI. This is the max NDVI. Wow. Right? Each pixel, because NDVI changes through the course of the year, this has picked the maximum value. This one has taken the median value. Typically, this is done for the growing season or seasonal wise. So you don't do a yearly composite for NDVI. Let's say you have studying agriculture and your growth season is just 2 months. You'll take this and say, give me the maximum NDVI. If you're doing yield prediction, typically it's correlated with the maximum NDVI of the plant that saw. So you can say, give me the maximum NDVI, and I can do some correlation with that. Yeah.
So you have like mean and max in the visualization, but you have 5 colors. So what happens?
Yeah, it's a good question. So we have min and max, and there are 5 colors. This first color will be 0. The last color will be 0.5, and this will be linearly interpolated. Yeah.
Could you explain again the line 37, the dot Regex p rename?
Yeah, if I don't do this, you'll see if I print my. Whenever you run this full syntax, Earth Engine will say whatever band you have, the new band that I will create will be the band name underscore the reducer name. So the name of the reducer will be you can see my images are now named B1 max, B2 max, and so on. If I do regex rename, it says just rename my bands. Wherever you see max, just delete that. So this is wherever the max will be replaced with empty. So now you can see my band names are the original band names. So this helps just keeping the same viz params. If I don't do this, then I have to change my visualization parameters to be, using max and so on. So. Yes.
The question is, so you were talking about agriculture and the need of finding the max, but most of the time you need to understand the phenology and the moment of the max. And that's, I don't know, I'm not sure if you can get that pixel level.
Yes, so there is a script and code available to derive the phenology parameters, start of season, end of season, length of season per pixel. So I'll add this to the notes. It's available. Again, there's a way to do this where you can say, understand the phenology, and from the phenology you derive when was the start of season, end of season, length of season at each pixel. And you'll get a band called start of season, where this is the day of year, the start of the season. And again, it's a library that's available in Earth Engine, and I'll add the link to that. You can implement that. But again, if you want to just see the phenology, the next script, we're going to do a chart of how the NDVI changes over time. So you can see this, but to derive those parameters at each pixel, there is code available, which I'll add to the notes.